All right, welcome back. We're going to go over several examples here of the factorization. Okay, example 10, fully factorize 3x minus 12. So these both have factors of common factors of 3 in there. So we factor the 3 out, and we are left with x minus 4. So that is this here, fully factorized. Can't do anything else with that. 6x squared plus 10. Let's see, there's no x's over there to factor out, but the 6 and the 10 both have a 2 in common, so that's really all we can factor out. 2 times, and 6 over 2 is 3, and we have x squared plus 5. And if you're not sure if you factored everything else out, you can factor and then look at what you have left on the parentheses. 3x squared plus 5, is there anything we can factor out of those? Any common factors? No, there's not, so that's all there is on that. Okay? Example 10, C and D, 2x squared minus 98. Can you factor anything out of both of those? Yes, we can. We can factor a 2 out. So we factor a 2 out, and we're left with x squared minus 49. Now, you look at x squared minus 49. Is there anything you can factor out of both of those? No, there's not. But this is a perfect square minus another perfect square. So this is going to actually factor out farther. 2. And then we're going to, let's see, x squared, the square root of x squared and the square root of 49. Square root of x squared is going to be x, so that's going to be what goes in the beginning of both of those. And then the square root of 49 is 7. That's what's going to go in the back half of both of those. And since it's a difference of squares, one's positive and one's negative. Okay, and remember, if you're ever unsure if you got the right answer, you can always multiply it back out, and you should end up with what you started with, right? So if we multiply this back out, x times x is x squared, minus 7x plus 7x, those x's go away. And then 7 times negative 7 is negative 49, so there's our x squared minus 49, and then there's our 2, so we know we got those, right. Okay, 16 minus 9x squared, again, a perfect square, and another perfect square. Can't factor this anything out of the 16 or the 9. But since we have perfect square and perfect square, we can just go straight to that anyway. Let's see. The square root of 16 is 4. So there's 4 is going to go in the beginning. Square root of 9x squared. Square root of 9 is 3. Square root of x squared is x. So we got 3x and 3x. One's positive, one's negative. And there's our difference of squares. These are hopefully, as you do more and more of these will become a little bit easier to recognize. Okay? All right, next one. Example 11. Well, we're still on example 11. Sorry, E and F on example 11. We've got t squared minus 10t plus 25. So, can we factor anything out of all of these? Nope, we can't. So now we're going to factor. Now this is that trinomial thing that we're talking about. The leading coefficient is 1. So if the leading coefficient is 1, we can do the little backwards technique. Find the factors of 25 that add up to 10. So I'm just going to simply write all the factors of 25 out that I know. 1 times 25, 5 times 5. Those are only two things, only sets of numbers that multiply together to get 25. Now, 1 plus, since that's a positive, 1 plus 25 is 26. That's not going to work. But 5 plus 5 is 10. Ignore the sign for now. So we know that our factors are going to be, let's see, we've got t times t to get to t squared. We know that our two factors are now going to be 5. Now if these have to add up to negative 10, what do the signs have to be? Negative 5 and negative 5 gives us negative 10. And that is our factored form. Okay? All right, F, 3b squared plus 36b plus 108. Can you factor anything out of all of these? We can get 3's out of both of those, and you can get a 3 out of this. So factor a 3 out of all of these, and this becomes a nicer problem. 3 times, and we have now b squared plus 36 over 3 is 12b. 108 over 3 is what, 30, is that 36? I believe that's 36. Okay. And now, this one here, we're basically just we can ignore the 3 and just try to factor what's on the inside. Now, this does happen to be a sum of 2 perfect squares, but if you don't see that, that's totally fine, because what we can really treat this as is just the leading coefficient is 1. What are the factors of 36? 36, 1 times 36, 3 times 12, and 6 times 6. What are the factors of 36 that add up to 12? So which ones of these add up to 12? The 6 and 6 do. So we've got B, 6, and 6. They have to add up to positive 12, so that's going to have to be positive 6 and positive 6. So there's our factored form, which shows that it was the sum of perfect squares. Okay, again, not super necessary that you remembered that it had the sum of 2 perfect squares form. You can just factor it out and notice that, oh, hey, look, it is 2 perfect squares. You could also write this as 3 times b plus 6 squared. That would officially be the little bit more correct way to write that. All right. Moving on. G and H, we have x squared minus 9x plus 8. Can we factor anything out of all those? No, we can't. So the leading coefficient is 1. So now we can just do the backwards technique. Factors of 8. Oops, sorry about that. That's not what I wanted. That's what I wanted. Okay. Factors of 8 are 1 times 8 and 2 times 4. Now, which ones of those add up to 9? The 1 and the 8 add up to 9. So I know it's going to look like this. X times x to get my x squared. And it's going to be 1 and 8. You can write it as 8 and 1. It doesn't matter. For these two to add up to negative 9, it's going to have to be negative 1 and negative 8 to get negative 9. And that's all factored out. Okay, this one here, can you factor anything out first? Yes, we can factor a 4 out of all of those, which will make this a lot easier to factor. 4 times, it's going to leave us with a squared plus a minus 6. Okay, and now we're just going to factor, we're going to ignore the 4 there, and we're going to just factor what we have left on the inside. So we are trying to find the factors of 6, 1 times 6 and 2 times 3, that have a difference of, that's positive 1a, right? So which ones have a difference of 1? The 2 and the 3 do. So we got a times a, and then we're going to put the 2 and the 3 in. It doesn't matter which one goes where, but we do know that they have to add up to positive 1. So it'll have to be positive 3 and negative 2, and those are, there's our this thing here all factored out. Don't forget the 4 at the end, because that's part of the factorization of this. Okay, last ones here. Fully factorized 10x squared plus 3x minus 4. Now, we cannot factor anything out of all of these, so that's where we're going to, and the leading coefficient is not 1, so we got to multiply the first by the last. So we're going to do 10 times 4, which is 40. And I'm now going to want to find the factors of 40. 1 times 40, 2 times 20, 4 times 10, and 5 times 8, right? And I got to figure out which one of those sets of factors has the difference, because that's negative, has a difference of 3. 5 and 8 have a difference of 3. So this is where I bring the 10x squared down, and I bring the negative 4 down, and I'm going to write this as a 5x and an 8x. Okay, these have to add up to positive 3, so this should be positive 8, and negative 5 will give me positive 3. Now group the first two, group the second two, and now we're going to factor. Remember to always put a plus in between these. All right, this one has a common, 10 and 5 have a common factor of 5, and it's got an x squared and an x, so we can get a 5x out of both of these. So we got a 5x out here. 10 divided by 5 is 2. X squared over x is x. And then we have minus 5x over 5x. That just simplifies down to 1. Okay, and then 8x minus 4, those both have a common factor of 4. Since this first term here is positive, we're going to factor out a positive 4. Right? And then we have 8x over 4. 8 divided by 4 is 2, and we still have an x there, and negative 4 over 4 is negative 1. Notice that these two match. That's what we wanted. So we factor that out, and there's our 2x minus 1 is one of our factors. After we factor those out, we're left with 5x plus 4. So those are our two factors. Okay, last one. Can you factor anything out of all of those? We can. They're all even, so we can certainly factor a 2 out. Can we also factor a 6 out? It does not look like it, so let's just take our 2 out here. So we have 2 times, and we're left with 3r squared minus 23r plus 14. Okay, now we're just going to ignore the 2, and we're going to now try to factor, the inside here. Actually, we are going to leave that like that. So leading coefficient is not 1, so we have to go 3 times 14. So we have to go 3 times 14, which is what, 42? So we got to come up now with the factors of 42. 1 times 42, 2 times 21, 3 times 14. Let's see, no 4s, 5s, but we do have 6 times 7. Okay, so now we got to figure out which ones of these add up to 23. There it is. 2 and 21 add up to 23. So we're going to bring this down here. 2 times 3r squared. And then remember the 14 comes straight down, plus 14. And then we're going to just rewrite this here as a 2r and a 21r. And then we just have to figure out what signs go in front so that we get negative 23. So that's going to have to be negative 21 and negative 2r gives us negative 23. Right? And we group the first two and group the second two. Put a plus in between those. We got the 2 out here. And we figure out what we can factor out of both of those. An r for both of those. And we have r times, and let's see, that leaves us with 3r minus 2. And then this one over here, since it starts with a negative, we got to factor a negative out. And those both have common factors of 7. So we factor negative 7 out, and we're left with negative 21 over negative 7 is 3r, and 14 over negative 7 is negative 2. Notice these two match. That's exactly what we wanted. So we have 3r minus 2 is one of the factors, and then r minus 7, the leftover, is the other factor. And then don't forget our 2. Our 2's got to come along here as well, and that's our factored form of this here. Okay? All right. If you have any further questions on this, please feel free to ask in class. Again, if you do not like this way that I've done the factoring here, there are other ways to do it. This just seems to be the easiest one for most students. So if you don't like this way, please ask, and I will be happy to show you some other ways as well. Thanks.